Hello students, let us learn what is concept of bandwidth or fringe width is. Now students, we know interference pattern consists of several bright bands and dark band. Then what is bandwidth? Bandwidth is nothing but distance between any two successive bright band or any two successive dark band, students. Let's say here is the example. You can see there is bright band, there is dark band, dark band. Distance between any two bright band would be what? Bandwidth. Distance between any two dark band would be what? Again, bandwidth. You can also call bandwidth as fringe width. It's one and the same. In order to represent it, we symbolically represent it as beta or x. Students, let us try to derive an expression for this fringe width. Now, in order to derive this expression, we need an experimental setup. So here is my setup. I'm having a screen with two slits. So whenever it would be exposed to one single source, it would be giving me an interference pattern on the optical screen kept exactly ahead of it. So here comes the source of monochromatic planar wave. Let us take example of laser, and that would be forming two coherent sources, and this two pattern of interference wave would give me a clear and steady interference. How does the pattern looks like? The pattern would exactly be made up of bright bands and dark band, and it would exactly seem like this. At position P, students, see there is central bright band. Above that there is first dark band, and above that there is first bright band. The same thing is repeated in the downward format, that is, it is symmetrical pattern. Getting it, students? So if I say that there are n number of bright band and n plus 1 number of bright band, then what would be the distances? Let me tell you, I'm going to assume it as x. So nth bright band would be having distance of xn. N plus 1th bright band would be having a distance of xn plus 1. So you can see this is my nth bright band, so xn is the distance, and for n plus 1 it is xn plus 1. But if I subtract this, if I take difference of the two distances, I'm going to get beta dash as fringe width. Students, I have considered bright band, so this would be beta dash for bright band, that's fringe width for bright band. In order to derive formula for beta dash, we need to consider condition of path difference. That is, path difference for bright band is xd by d equals to n lambda. So for nth bright band it would be exactly same because n are similar. So xn d by d is nothing but n lambda. And students, what would be xn equals to? Xn would be nothing but equals to n lambda d by d. Likewise, for n plus 1, students, just do one single thing. Instead of n, substitute n plus 1. And what is the value we would be obtaining? We would be getting xn plus 1d upon d is equal to n plus 1 lambda. What would be xn plus 1? Xn plus 1 would be equal to n plus 1 lambda d by d. But this is not what is fringe width is. We need to subtract it. So on subtracting this, my values would be like n plus 1 lambda d by d minus n lambda d by d would give me in turn directly lambda d by d. So on LHS, what you can see, this is nothing but beta dash. And what is beta dash? Beta dash is distance between two bright band. So what is beta dash equals to now? Beta dash is equal to lambda d by d. So students, this is for bright band. Exactly in the similar format, we can go for dark band. So the diagram is same. Point is same. Point P as CBB, that is central bright band. And we can say that there is mth and m plus 1th dark band available in the pattern. So the distance of mth dark band and m plus 1th dark band would be like xm and xm plus 1 respectively. So these are the distances of mth dark band and m plus 1th dark band, and the difference of these two would give me nothing but beta double dash. Beta dash was for a bright band and beta double dash would be for dark band. How would we obtain beta double dash? The same format we would follow, but this time the condition would be for darkness. path difference is equals to 2m minus 1 lambda by 2, and the path difference for mth dark band would be this same thing. xmd by d is nothing but equals to 2m minus 1 lambda by 2. Students, what would be xm equals to? Just rearranging the terms, I'm going to get this value. And for m plus 1, wherever there is m, substitute m plus 1. The format would be looking exactly in the above line. Now, by simplifying, xm plus 1 would be nothing but equals to 2m plus 1 lambda d upon 2d. But this is not what is required. We would say xm plus 1 minus xm is beta double dash. So let us subtract this. On subtracting these two, can you see, students, there is common denominator. So the numerator would be directly subtracted. On subtracting it, we would say that xm plus 1 minus xm is nothing but equal to lambda d by d. And in turn, you can say that this is nothing but going to give me beta dash as lambda d by d. So students, this is what? This is beta double dash for dark band. And in exactly similar manner, we can summarize the whole thing, right? Beta dash was lambda d by d, beta double dash is lambda d by d. Then what is going to be the conclusion? The conclusion is beta dash is exactly equal to beta double dash. But students, if these both are having same magnitude, can we say that the fringe width beta is lambda d by d in common terms for both bright band and dark band? So my conclusion would be fringe width of the bright band and dark band are exactly same. So this is the conclusion we made from this expression. Thank you.